Hi and welcome to another carpenter tutoring tutorial. I'm Amy and today we are going to talk about how to solve for variables in equations that will have variables on both sides of the equal sign when we start out with those equations given to us as word problems. So in this case we have to translate the word problem to a mathematical equation and then figure out how to solve that equation for the value of our variable. Let's check out the problem we have in front of us. It reads, you can buy used binoculars for $40 or you can rent a pair. Either way, you must rent a neck strap. Renting just a neck strap is $3 per hour, while renting the binoculars and a neck strap is $6 per hour. How many hours must you birdwatch for buying and renting the binoculars to be equal? When we have a big word problem like this, what I first like to do is try to break it down to its most basic question. So our most basic question is, how many hours do we have to do this bird watching for in order for buying the binoculars and renting the binoculars to be equal? So what it sounds like to me is that we are trying to find the meeting point or the equivalency point for two different types of costs. We have cost scenario number one, in which we buy those binoculars and rent the strap, and we have cost situation two, where we rent both. Let's figure out mathematically how we can represent these two cost scenarios. So in cost scenario number one, I have to buy my binoculars. Well, we learned that we can buy used binoculars for $40. And so I know I'm going to have a cost of at least $40 for this. But I'm not just buying those binoculars, I also have to rent the neck strap. And we learned that that's $3 per hour. As soon as I see that I have per hour or unit per unit, in this case dollars per hour, that tells me this is a rate, and more likely than not, my variable is going to be included somewhere in this rate. Going back to my main question, I see that I'm being asked for how many hours I must go bird watching, and that tells me the number of hours is going to be my unknown value. Since I see per hour in the units for the rentals, that tells me that the dollars that I have must be multiplied by the number of hours that I am using them. And so I can represent this $3 per hour as $3 for every hour or times h that I am bird watching. 3h is a representation of the cost to rent just the neck strap for however many hours I may choose to use it. These two costs together, the $40 for buying the used binoculars and the 3h for the neck strap, are going to give me the total cost for cost scenario one, as long as I bring them together, and I do that using addition. Then in my second scenario, I'm just renting both materials, and we learn that that is $6 per hour. We've already decided that this per hour means that I am multiplying the dollar value by however many hours I choose to use that equipment, and so I can represent the cost scenario 2 where I rent both items as 6h. Again, because we learned that renting both costs $6 per hour. Now that I know how I can mathematically represent these two cost scenarios, I have to figure out what the equation needs to be to relate these. I learned that I'm looking for the place where buying and renting the binoculars is equal. So I'm looking for a place where both cost scenarios are equal. That means I have to take my two cost scenarios, 40 plus 3h and 6h, and make them equal to each other. Now that I figured out this part, I can solve a little more easily. Since I'm now looking at this as a mathematical equation, I can think about what I need to do to isolate my variable. I see that I have that variable on two sides or both sides of the equal sign, and so I'm going to have to move one instance of that variable over to the other side of the equation. Mathematically, I could do this either way, but I see that if I move the 3h over to the 6h, then I'm going to have my number 40 just on one side of the equal sign and my variable on the other side of the equal sign, which is exactly what I want to accomplish. So I'll go ahead and do this. Since I have a plus sign in front of 3h in my equation, I'll get rid of it by using the opposite sign, which will be minus 3h. And I have to make sure to do that on both sides. Once I do that subtraction, I get 40 equals 3h. Now I have numbers on one side, variables on the other. My last step is to get h completely on its own. I see that 3 is currently connected to h in a multiplication relationship, and so I can break that relationship with the opposite operation, in this case division. So I'll divide by 3 on both sides because I'm dividing by what I want to get rid of, which is that coefficient of 3. When I divide by 3 on both sides, I end up with 13 1/3 equals h. Since we're working on a word problem, I always have to go back and relate this value to the situation of the word problem. So we're looking for hours of bird watching we have to do to make these costs equal out. That means I can use the final or main question of this setup in order to create an answer. So instead of just saying 13 1/3, I need to put that in the context of the problem by saying I can bird watch for 13 hours and 20 minutes, turning that 1/3 of an hour into 20 minutes to have both cost types be equal. It's a little bit of a mouthful, but we always want to make sure that we relate the answer of our word problem back to the original scenario and the main question that was being asked. So I've now put this 13 1/3 into the context of hours we use for bird watching. I hope it's been helpful to walk through this example together. As always, if you have any questions or other topics that you'd like to see discussed, please let me know in the comments. If you enjoy our content, I hope you'll consider liking this video and subscribing to our channel. Thanks so much for spending part of your day with me, and I'll catch you next time.